Hey, what's going on, guys? It's Bella here. I recording stuff on YouTube. Check the description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel. Give me a big thumbs up to support it. And this is called counting bits. Given a non-negative integer number num for every number I in the range of 0 till num inclusive, calculate the number of zeros of ones, not zeros, of ones in their binary representation and return them as an array. Well, you can check this out. Follow up. It's very easy to come up with a solution with runtime, but can you do it in linear time, big of n, possibly in single pass? Space complexity should be big of n. Can you do it like a bus? Do it without using any built-in function like built-in. Alright. Well, I'll show you the solution and then I'll explain it to you. I'll explain how to do that. So first you need to create an array. The length of that array will be num plus 1. And then you're looping through this. You just say you create a for loop int I equals to 1 and I is less than or equal and equals to num and I plus plus, and here you say array at I equals to you do arithmetic right shift, so that means that you divide the value by 2 you divide the value by 2, so you say array I and 1 plus plus I and 1, and finally you just need to return an array. Let's run this code or just submit. First try, yeah, success. There we go. Great. So what does it mean? First we create an array. The length of that array will be num plus 1. Then we create a for loop. We start from 1. Initially, like let's see this example or just this. Like there is much difference. Let's start with the first example. Like we got input 2, then we got an array of 3 elements, right? So the first element will be 0. Then we start from this is a 0 position, this is a 1, this is a 2. Yeah, so we start from 1 at this position. We calculate I divide by 1. That means that we have 1 in decimal representation will be like 1, and in binary representation that equals to 0, 0, 1. What we do is that we divide by 2, so 1 we say 1 divide by arithmetic right shift we do divide by 2, that will be 0, because we just kind of like like shift the bits to your right. So we got like 0, right? So we just shift, we add, we put 0 at the first position, and we shift the elements to your right. So we do like this, and then we remove the last character. That's it. So we just kind of like, the result will be like 0. Here we got like 0. Then we need to add I and 1. As you know, guys, there is a bitwise operator, it's called AND, and that means that 0 and 0 equals to 0, 1 and 0 equals to 0 as well, and 1 and 1 equals to 1. Yeah, that's it. So what we're gonna do is that we say I, which is 0, 0, 1, 0, 0, 1. We say and 0, 0, 1, and the result will be, here we got like 1 and 1, which is 1, right? 0 and 0, which is 0, and 0 and 0, 0. So we got like 1. So we say 0 plus 1 will be 1. This position, we currently at I, so we put 1 into that position, at this position. Then we move, we increment I by 1, and here we got like 2, right? So 2 in binary representation will be like 0, 1, 0, right? And 3 will be like 3 equals to 0, 1, 1, right? So we need to think about 2. What we're gonna do is that the same process, we say I, which is 0, 1, 0. We do the right shift, so we say divide by 2. That means we need to shift these bits by 1 to your right, so we do kind of like this, and then we return the, we just remove, we get rid of the very right bit. So that means that 2 divided by 2 will be 1. The result will be this one. This is the result, like 1. Here we got like 1. And 1 plus 1 plus 1 plus I equals to 0, 0, 0, 1, 0, and we do this step, and 0, 0, 1 equals to 0 and 1 equals to, look at this table, 0 and 1 equals to 0, and 1 and 0 equals to 0, and 0 and 0 equals to 0. So the result will be 0, right? So 0 plus 1 plus 1 equals to 1 will be 1, so we just put 1 at this position. Let's go on. Like, suppose we need to calculate till 3 inclusive, so I mean till 3, like, right, till, you know, like 2 and 3. In order to do that, we do the same process. We say 3 equals to 0, 1, 1. So what we're gonna do is that we say we do the right shift. We say 0, 1, 1, when we just shift the bits to your right. So we say we put 0 and we get rid of the very last bit. So 3 divided by 2 will be 1, equals to 1. And then we plus 1 plus I here, which is 0, 0, 0, 1, 1 and 0, 0, 1. This one equals to 1 and 1 equals to 1, 1 and 0 equals to 0, and 0 and 0 equals to 0. So we got here 1, and 1 plus 1 equals to 2, so we just put 2 right here. That's it. That's the whole problem. I think that's super easy. You just need to come up with that solution. You just need to know about the bit manipulation, these operations like with bits. That's it. Thank you guys for watching. Leave your comments below. I want to know what you think. Follow me on social medias. Subscribe to the channel. Give me a big thumbs up to support it. And see you next time. Thank you. Bye.